This is a video lesson for Lesson 6 of our Angles and Planar Figures unit. The Lesson 6 learning target is I can use varied protractors to distinguish angle measure from length measurement. This is a pretty wordy learning target. Essentially what I would call this lesson is how to use a protractor. So we're going to be talking about protractors and doing a couple demonstrations of how we actually use a real protractor to measure angles. So let's go ahead and jump into the first part of our lesson, which is a quick discussion on what is a protractor. A protractor is a tool that looks like this. It's a semicircle, and it's a tool that's used to measure different angles. It has all of these little tick marks along the side of the outside here, and each one of those little tick marks represents 1 degree. And so you might be familiar with some popular angle types like 90 degrees. Well, that would be right here. This is 90 degrees on the protractor. So essentially how it works is we're able to look at an angle and measure it based on where the end or the lines fall through or run through on the protractor. So for example, if we had, I'm going to put another line here. I already have one line that's going through 0 here. If we had a second line here that we can run it along the outside of the protractor to create an angle. So right here I'd have a 90 degree angle. This line is going directly through up through 0 and then 90 degrees. And as I get smaller, I get to 80 degrees right here, 70, 60, 50, 40, 30, 20, 10 degrees. And I'll get all the way down to a 1 degree angle right here. So as I go from 0, it's growing. Here's up to 90 degrees. And then as I go past 90 degrees, even though the number 80 is on here, since I have an obtuse angle, this angle is now 100 degrees, 110, 120, 130, 140, 150, 60, 70, and 180. So depending on where the second line falls is what the measurement of the angle is. So right here, I have a 45 degree angle. Now I'd have a 20 degree angle. Going to the other side would be a 110 degree angle. Back to a 90 degree angle. And all the way down to a 180 degree angle. So depending on where the two lines fall is what the measure of the angle is. So let's go back to a 90 degree angle here. Actually, it looks a little bit more like 91. So we're able to use this tool to measure angles in the unit of degrees. And so the next part of the video, I'm going to actually using the camera to show you how you can use an actual protractor to measure an angle that is drawn on a piece of paper. So in this part of the video, I'm actually going to be showing you how to use your protractor to measure different angles that are drawn on a piece of paper. And so when we're using our protractor, there's a couple things to be looking out for. The first thing is the little hole right here. I don't know if it has a specific name. I guess I'll have to research. But there's this little hole that's right on the bottom. It falls right below 90 degrees. And there's two lines that go out from either end of it. That's going to be really important when we're trying to measure our angles. So what we're going to do is we're going to place that hole right on the vertex of the angle. And then we're going to make sure that one of those little lines that's coming off the side of that angle is lined up exactly with one of the lines on our angle. I'm actually going to shift the paper over so we can see this. So I'm putting the hole right on the vertex and I'm lining up the line so it's exactly on that one of the lines of the angle. And what this does is if you look over, this sets one of our lines exactly at 0 degrees. And this allows us to now measure starting from 0 degrees and moving up. So we're going to be counting up 10, 20, 30, 40, 50, 60, 70, 80, 90. It's past 90 degrees, so we know it's an obtuse angle. We get to 100, and it looks like it falls between 100 and 110. So we're going to have to actually count the small little tiny tick marks here to see where exactly, what measure this angle is exactly. So we're at 100. 101, 102, 103, and it looks like it falls right on 104 degrees. So the line goes exactly through 104 degrees where that tick mark is. So since this line goes through 104 degrees, we would say that this angle's measurement is 100, oops, not 140. That would be way too big. 104 degrees, which is just past 90. So since it's a greater than 90 degree angle, we would name this as an obtuse angle. It's greater than 90 degrees. It's 104 degrees. So using that same strategy, we can measure other angles as well. This one looks a little different because it's not exactly flat on the page like this one was, or the bottom of the angle isn't where we want it to be. So what we're actually going to do is we're going to rotate the page so that we have the bottom of the angle somewhat flat and facing towards us. This will allow us to use our protractor in the exact same way. I'm going to find that hole on my protractor. I'm going to put that right on the vertex and then do my best to line up this line. And remember, my goal is for the end of this line to be right on 0 degrees. So the hole's right on the, there we go. So I have this line right here that falls on the line, and then this line right here is also on the line. So now this will allow me to measure this angle, and we're counting up from 0 here. So I'm going up to 10, 20, 30, get to 40, and we're going past 40, and so I'm going to look at the small tick marks out here. We have 40 degrees right here. Looks like it goes 41 and then goes right through 42 degrees. So we would say that this angle has a measure of 42 degrees. And since 42 is less than 90, going back to our previous lessons, we would call this an acute angle. So these two angles are both pretty simple because they were long enough to go through the protractor when we lined up our first line. But this isn't always the case. Sometimes we're given angles that are really, really small, or the lines are drawn really, really small. And in that case, we need to use a little extra strategy in order to measure them. So I have a few smaller lines here that I'm going to demonstrate how we can still use the same protractor to measure the lines. So you can see that when we put the hole there on the vertex and we're trying to get it lined up at 0, it's tough to read because this line, we can tell it's going in this direction, but we don't know exactly where it crosses the protractor. And we really don't know if we've lined it up exactly at 0 degrees for the other line too. So what we're going to do is we're just going to extend both of these lines using the straight edge of our protractor. So I'm going to take the protractor, I'm going to trace along the line, and then I'm going to extend it a little bit further. So when we do this, we're just creating a longer line so we can measure it a little easier. I'm going to make sure it's long enough here. I'm going to keep going just a little bit further. I want to make sure it's nice and straight. This is where accuracy is really important, to make sure we're drawing nice straight lines. And I'm going to extend this second line as well, make sure I have it nice and long so I can get a really accurate measure of this angle here. Oops. So you see my drawing was a little off there, so I'm going to actually go ahead and erase. My pencil slipped off my straight edge. I want to make sure I'm drawing really straight and accurate lines, so I'm going to go ahead and try that one more time. See if I can get it right this time. Alright, that feels a lot better. I kept it on the straight edge the whole time. Yep, that's a lot straighter. So now I have this nice long, these long lengths of the angle, long lines off the angle, and this will allow me to measure more accurately. So once again, I'm putting the hole of the protractor right on the vertex of the angle here, where the two lines meet to form the angle. Now I can check to see that this line falls on the first line here, and look at that line goes straight through 0 degrees. So I'm going to count up to get to the other line over here. So it'd be tempting to count from this side over, but I'm going to count up here. So I'm going 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. And looks like our line is somewhere past 130, so I'm going to go up to the end here. Here's 130 right here, 131, 132, 133, 134, and it looks like it goes exactly through 135 degrees. So we would say this angle has a measure of 135 degrees. And since this is 135 is greater than 90, we would call this an obtuse angle. Okay. And you might be wondering why there are numbers on both sides. Well, this is because I can actually measure from either side. So if I were to start with this line first, I could use the same process of lining up the hole on the vertex and making sure my line goes through 0 degrees, just like this. Then I can actually count this way using the outer numbers, 100, 200, 300, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. And then once again, you can see that I get to 135, except for this time I counted from left to right, not from right to left, and I use those outer numbers. So the outer numbers and inner numbers all depend on where we start to count from. So if we're starting from the left, we're going to count using the zeros on the and the outside numbers. If we're starting on the right, we're going to start with the inner numbers counting from 0. So it's always helpful to remember to start from 0 when you're counting your angle, and that's going to help you get a more accurate measurement. So let's take a look at one more example here. We have a teeny tiny little angle drawn here on the bottom. This one definitely will not go all the way through our protractor, so we're going to need to extend both of these lines here to make sure that we're able to get an accurate measurement. So I'm going to go ahead and trace over the line and extend it out really far. I want to make sure this line is really extended out far here so I know for sure it's going to go through the protractor. And I'm going to do the same thing with this first line. I'm going to extend it out nice and long so that I can get an accurate measurement. Okay, so I've got two nice straight lines now, and I'm hoping that I can get this through. It looks like it'll go through the protractor. And so same process as the previous angles. I'm lining up this hole right on the vertex here, and I'm making sure that this line is right on top of the first line, and then that line runs through 0. And look, it does right there. So it's 0. And I'm going to count up here. So I'm going to count 10, 20, and 30. And it looks like this is kind of interesting because our line splits right down the middle of two whole number measures. So we're going to go 30, 31, 32, 33. So it looks like it's right between 33 and 34. So we could call that 33 and a half degrees. If we were able to determine which one it's closer to, it looks like it's a little bit closer to 33. I would say that it's exactly 33 and a half, or it's closer to 33. It's approximately 33 degrees, but either way, it's less than 90 degrees, so we would call this an acute angle. So that does it for lesson 6. So hopefully at this point you're feeling pretty comfortable with using a protractor and measuring different angles to see how many degrees they measure. So at this point you should be able to work your way through the lesson 6 problem set. And as always, if you get stuck or need a refresher on any of the concepts, come on back and rewatch any part of the video that you need. So good luck with the problem set, and thanks for watching.